Okay, welcome back. I'm trying to solve some of the problems on the limits, which is of the form 0 by 0 or infinite by infinite. Let us try to look those kind of problems. Okay. Now, suppose if I have the limit like the limit x tends to 1 x square minus 4x plus 3 divided by x square, okay, minus 3x plus 2. Okay, let us try to solve this problem. Now if you look at this problem, uh, if I put x in the numerator as 1, okay, so I get 0, so this becomes 0 by 0. Fine. Okay, so let us try to evaluate this further. I would use L'Hopital's rules here to solve this problem. Okay, so let us use this L'Hopital's rule. Now, this rule, you have two functions in the numerator and denominator. Let me put that. So if I substitute, if I differentiate this numerator and denominator, so I get 2x minus 4 in the numerator, and this would be 2x minus 3. Okay, when I differentiate with respect to x, because x being a variable here. So now I have done this. So now if I substitute it, so when I substitute this, so I get minus 2 here, and here I'll get minus 1. Okay, so this would be 2. The answer is 2 here. Fine. Okay, let me try to solve another problem. Okay, so if I take another problem and again applying the L'Hopital rule here. Okay, let me again explain the previous problem which I have said. So that was I have differentiated with respect to x in the numerator and differentiated with respect to x in the denominator also. So I got that result. Okay. Let me try to solve another problem. Okay. Now the limit, which is limit x tends to 2. Okay, so x cube minus 2x 3x, okay, minus 2 divided by uh, 2x square 2x square minus 5x, okay, plus 2. Okay, now if I substitute x as 2 in the numerator and x as 2 in the denominator, I get that as 0 by 0. So which is an indeterminate form, again by applying L'Hopital's rule. Again by applying L'Hopital's rule, let us differentiate with respect to x for the numerator and differentiate with respect to x for the denominator. What I get as 3x square minus 3, and this is 4x minus 5. Now if I substitute x is equal to 2, I get 9 by 3, and which is 3. So that is the solution for the problem. Okay, let me again look into some other problem. Okay. Okay, now if I have the limit as x tends to 0, uh, this is tan x by x. Now let us try to solve this. Okay. Now as and when if I substitute x is equal to 0, so I get this as 0 by 0 again. Okay, and hence again it is indeterminate form. Now let us again differentiate this by numerator and by x for the numerator and for the denominator. Okay, so by using L'Hopital's rule here again. So I get limit x tends to 0. So differentiation of tan x becomes secant square x, and differentiation of this becomes 1. Now if I substitute x is 0 here, so secant this becomes uh, uh, 1, so I get 1 as a result. Okay, so let me try to solve another problem. So if I have limit x tends to 0, okay, a power x minus b power x by x by x. Now let me put x is equal to 0 here. So when I substitute x is equal to 0, mm, I get here as mm, as a power 0, and again this becomes 0 here. Okay, 0 by 0. So again it is indeterminate when you put x is equal to 0. So uh, now that you have uh, found that, so let me differentiate with respect to x in the numerator and differentiate again with x for the denominator. So I get differentiation of this would be a power x log a minus b power x, this is log b by 1. So by using L'Hopital's rule, Now let us substitute x as 0. So I get log a minus log b, which is log of a by b. So that is the solution for this. Let me try to solve another problem. Okay. Okay. The next problem looks like this: as limit x tends to 0. Okay. X cos x minus log of 1 plus x divides by x square. Now when you put x is equal to 0, again I get 0 by 0. Okay. Now using L'Hopital's rule here again, once again, if I substitute, uh, that is differentiating x with respect to x in the numerator and differentiating x uh, in the with respect to denominator. So I get here for numerator, which is in the form of x u into v. Okay, so this would be x differentiation of cos is minus sine x, and so the plus, and I get uh, differentiation of that will be cos x here alone. Okay, so this differentiation would be 1 by 1 plus x. Fine. That's with the numerator. Now the denominator would be 2x. Okay. Now again, if you substitute x as 0, so again this becomes 0 by 0. Okay. Again, by applying L'Hopital's rule, let us substitute it. So again differentiate with respect to x for the numerator and differentiate with respect to x for the denominator. So I get minus 2 sine x. Okay, minus 2 sine x minus x cos x. Okay, plus this would be 1 by 1 plus x whole square. Okay, divided by 2. Now when you substitute x as 0, sine 0 is 0, cos 0 is 1, uh, you get minus x. This term will be 0. So I'll have 1 in the numerator and denominator I'll have 2. So this leads to 1 by 2. So let us see another problem. Okay, on the limits. Again, by using L'Hopital rule and so on. So if you have any queries, you can send it to my email ID. Okay. Uh, so let us see another problem. As limit x tends to 0. So you have x e to the power of x minus each question carries around 2 to 3 marks. Okay, based on the problem to problem. Okay, so that's that. So let us again put x is equal to 0. So I get and the numerator as 0 by 0. Okay, so let us again differentiate with respect to x in the numerator and differentiate with respect to x for the denominator by using L'Hopital rule here. Okay, again by using L'Hopital rule. So for this, I'll have x into e to the power of x and e to the power of x, and this will be minus 1 by 1 plus x. Okay, divided by this is 2x. Okay, so again when I substitute, this becomes 0 by 0. Okay, again applying L'Hopital rule here. Okay, so let's substitute that here once again. I get limit x tends to 0. This would be again x e to the power of x plus e to the power of x. So you have 2, so it is 2 e to the power of x. Okay, and this would be 1 by 1 plus x whole square. So that's that. Okay, and the denominator is 2. Now when I substitute x as 0, I get 3 by 2 on the whole. So let me try to solve another problem. Okay, for what, if you want to watch more videos, it is available in the YouTube. Uh, I have put two playlists here. Uh, one is of IIT Mathematics and one is of Engineering Mathematics. Okay, as well as aptitude related. Okay, so let us move on to the next problem here. Okay, now limit x tends to 0. Okay, 1 minus cos x divided by x log of 1 plus x log of. Again, if I substitute x is equal to 0, I get 0 by 0 here once again. Okay, now again using uh, L'Hopital rule here. Okay, let us apply it here. So limit as x tends to 0, differentiating with respect to x for the numerator, I'll get this is minus and this is plus sine x. Okay, and in the numerator x, you have x and log of 1 plus x. So that would be u into v. So that is x into 1 by x here plus, and this would be log of 1 plus x here. Okay. Now again, if I substitute x is equal to 0, I get 0 by 0 again. So again, using L'Hopital rule here, again, limit x tends to 0, differentiating with respect to x. So I get sine becomes cos x here. And again, this, if I try to simplify it, I get 1 by 1 plus x. And this is minus of x alone. Okay. And I'll get 1 by 1 plus x square. Okay. On the whole. Okay. So that's what I get. Fine. So this would be, if I try to simplify this, 1 plus x here. Okay, if I take to the other side. So this would be divided by, 1 plus x whole square. Okay, when I try to simplify it further. Okay, so now in this case it is 1 by x, 1 by 1 plus x here. Okay, now again by applying L'Hopital rule here, sorry, if I put x is equal to 0, let us see whether L'Hopital rule required or not. So when I substitute this, I get here as 1 by 2. So I don't require L'Hopital rule since I got the value of this. Okay, so let us try to uh, solve some more problems. Okay, on the limits. Okay, please send me some comments on this. Which will be helpful for us. Okay. Let us see another problem. Limit x tends to 0. Okay. So that is x minus tan x divided by x cube. Now this again, if I substitute, so it is 0 by 0. Okay. So I got this. Okay. If I substitute it, I get. Now again, L'Hopital rule here again. If I substitute, put here. Now differentiating numerator with respect to x and with respect to x in the denominator here. So I get limit x tends to 0. So x is 1 minus tan square is secant square x divided by, this should be 3x square. Again, if I substitute x as 0, I get 0 by 0. Again, you have to differentiate with respect to x for the numerator and for the denominator. So I get this is minus 2 secant x. Okay, and secant x is secant x tan x. Secant x tan x, and this should be 6x square. Okay, I'm sorry, 6x, because we differentiate this. Now again, if I substitute x is equal to 0 here, I get 0 by 0 again. Okay. Now let us again use L'Hopital rule here. So again, limit x tends to 0. This should be like 2 secant square when you cancel it. So I get 1 by 3. Okay, minus 1 by 3 here, and secant square x. Okay, tan x divided by x here. Okay, what I get 0. Okay. Again, let me apply the L'Hopital rule here. So I get minus 1 by 3, limit x tends to 0. Okay, limit x tends to 0. 2 secant square x tan square x, okay, plus secant to the power of 4 divided by this will be 1. Okay, so when I put x is equal to 0, I get this as minus 1 by 3. So let me continue for the next session. Thank you for listening. I'll be back soon.